Hi all, welcome to CS407 Distributed Computing. This is a course included in the 7th semester BTech program under KTU, Kerala Technological University. My name is Josnae and I am the instructor for this course. Let me start with some general information on this course. The course objectives are to introduce the fundamental principles of distributed systems, its technical challenges and the key design issues, and to impart knowledge of the distributed computing models, algorithms and the design of distributed system. Course prerequisites are database management systems, computer networks and operating systems. For the contents in first two modules, you can refer this textbook. Distributed Systems. The title of the book is Distributed Systems, Concepts and Design. Authors are George Coloris, Jean Dollimore and Tim Kimball. These are the topics which I am going to explain today. What is a distributed system? Need for distributed system. Examples of distributed system. How to characterize a distributed system. Then centralized system versus distributed system. Let's begin module 1 with the definition of distributed system. A distributed system is one in which physically separated, independent computers connected via computer networks, they communicate and coordinate with each other by means of message passing in order to achieve a common goal or to solve a problem that cannot be individually solved. Before going into the detailed explanation of this definition, I will tell you a real life experience of me. I have a SBI account. I opened this account years before at Idachira branch near Info Park. Whenever I need to solve any money related matters, I usually prefer to go to this branch of SBI, and it is very near to my house. In the year 2017, I went a trip to Malaysia. When I was there, there aroused a urgent need for a transaction, and I went to an SBI branch there where they could provide me all my details, even though I had only provided my details for Idachira branch at the time of account opening, and I was able to finish my money related matters from Malaysia itself. You know, SBI, State Bank of India, it has branches all over India. Also, it has branches on several countries. And a customer of this bank, regardless of where he or she is, they can do transactions if there is a branch of the same bank at their place. How could this be possible? I hope everyone knows the answer. You have studied computer network in the previous semester, right? And you know, if the computers at different branches are connected, and if they can able to communicate and coordinate their activities, this enables the computers to share resources, right? And the computers can easily solve a problem by communication and coordination by means of message passing, right? And a banking environment needs such kind of infrastructure to satisfy their customers, right? And this kind of infrastructure is known as distributed system. I request you to once again read the definition. A distributed system is one in which physically separated independent computers. So you know, there are computers at each branch, right? And the computers of different branches are connected together. That means the physically separated, the spatially separated computers, the geographically dispersed computers are connected, right? Through computer networks. And these computers can able to communicate and coordinate their activities by means of message passing. Message passing, you know, by means of internet protocols or through TCP/IP networks, right? That you know. So the physically separated, spatially separated, geographically dispersed independent computers means each computer has its own memory and own processor. The computers are independent. They do not share memory. These physically separated independent computers connected through network communicate and coordinate by passing messages for solving a problem which cannot be solved by a single computer. Such kind of infrastructure is called a distributed system. And a branch of computer science that solves computational problems using distributed system is called distributed compute. Distributed system is a loosely coupled system. In distributed computing, several computers are involved, and the computers participating in the distributed computing process are independent computers, in the sense the computers do not share common memory or common clock. They do not depend on each other. They are independent. They talk to each other through communication network by means of message passing. And you know, in distributed computers, the autonomous systems work on the divided task. But these computers are spatially separated, right? They may be located in the same building, or in the same state, or in the same city, same country, or they may be dispersed over the world. Peer-to-peer networks, wireless sensor networks, grid computing, cloud computing, all come under distributed computing. Google, YouTube, Google Map, etc. are the applications of distributed systems. Parallel computing systems are tightly coupled systems. That means a parallel computing system requires one computer with multiple processors. Multiple processors within the same computer execute instructions simultaneously, and all the processors work towards computing the same task. Thus, they have to share memory. Computational astrophysics, geoprocessing, medical imaging, and drug discovery are some of the applications of parallel computing. Turning your attention to the need for a distributed system. First point is performance. The distributed system can be designed in such a way that the performance of a particular application run on a distributed system should be better or equal to that of the same application run on a single processor system. You know, in distributed computing, several computers are involved, right? That means lots of CPUs, disk, memory are working in parallel, right? Next is fault tolerance. Fault tolerance is the ability of a system to continue functioning in the event of partial system failure. A service used in distributed system to tolerate fault is redundancy. Means make use of redundant components. The basic idea behind redundancy is avoiding single points of failure by replicating critical hardware and software components, so that if one of them fails, the others can be used to continue. A system is said to be designed to tolerate k failure. At least k plus 1 replicas are needed. Next point, physical reasons, right? Like I explained in the banking example. Next is isolation. A system, the distributed system design supports isolation of computers. That is, your stuff runs on your computer, my stuff runs on my computer, while these computers can talk to each other. This can be considered as a privacy preservation technique, also a security technique. The next point is resource sharing. The resource means which includes both hardware resources like disk, printers, etc. Software resources which includes files, windows, data objects. The existing resources in distributed systems can be accessed or remotely accessed across multiple computers in the system. Computers in distributed system can share both hardware and software resources and data. Hardware resources are shared for reductions in cost and convenience. Data is shared to achieve consistency and to exchange information. Let's look at some other definitions of a distributed system. A distributed system is a collection of autonomous computing elements that appears to its users as a single coherent system. This definition refers to two characteristic features of distributed system. The first point is a distributed system is a collection of computing elements, each being able to behave independently of each other. A computing element, which we will generally refer to as a node, can be either a hardware device or a software process. The second thing in this definition is that users, be they people or applications, believe they are dealing with a single system. This means that one way or another, the autonomous nodes, independent nodes, needs to collaborate, right, to solve computational problems. And how to establish this collaboration lies at the heart of developing distributed system. The distributed system appears to its users as a single system. This means that the end users of the system is unaware of the processes, data and control that are dispersed across the computer network. And achieving the single system view is also a challenge of the distributed system. The second definition is distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. Other definitions of distributed system includes a distributed system is one in which components located at networked computers communicate and coordinate their actions only by passing messages. A distributed system is a collection of computing elements, each being able to behave independently of each other. The size of the distributed system may vary from a handful of devices to millions of computers. Then going to the second definition, I think this second definition has a significant feature of distributed system that you should note. A distributed system consists of a collection of autonomous computers linked by a computer network and equipped with distributed system software. In order to achieve the advantages of the distributed system has a set of softwares. This software enables computers to coordinate their activities and to share resources of the system hardware, software, and data. To assist the development of distributed applications, distributed systems are often organized to have a separate layer of software that is logically placed on top of the respective operating systems of the computers that are part of the system. The figure shows 4 networked computers and 3 applications, of which application B is distributed across computers 2 and 3. Each application is offered the same interface. The distributed system provides the means for components of a single distributed application to communicate with each other, but also to let different applications communicate. At the same time, it hides as best and reasonable as possible the differences in hardware and operating systems from each application. In the sense, middleware is same to a distributed system as what an operating system is to a computer. A manager of resources offering its applications to efficiently share and deploy those resources across a network. Next to resource management, middleware offers services that can also be found in most operating systems, including facilities for inter-application communication, security services, accounting services, masking of and recovery from failures. The main difference with the operating system equivalents is that middleware services are offered in a networked environment. Let's look at some examples of distributed system. First one, web search. Web search is an application of distributed system. A web search engine is a software to search information on the World Wide Web. You may be familiar with different search engines, right? Google, Bing, Baidu, Yahoo, etc. And this web search is a very complex task, as current estimate states that the web consists of over 63 billion pages and 1 trillion unique web addresses. When you Google something, behind the scene many computers communicates and coordinates to provide you an answer. But the user perceives the distributed system as a single entity rather than as a collection of autonomous systems which are cooperating. When you Google something, the Google usually returns the ordered list of the most relevant results that matches your query by searching the contents of the web, right? But you are unaware of the collaborating systems behind the scene, right? The users are unaware of where the services are located and data transferring from a local machine to a remote and vice versa. The distributed system hides this complexity from the user. Another example of distributed system is massively multiplayer online games. A massively multiplayer online game is an online game with large number of players, typically from hundreds to thousands. Maybe you participated in such kind of game in which people at different locations can play together, right? And this MMOG employs peer-to-peer communication model, which means the players can send messages directly to each other. Now let's have a turn at the fundamental characteristics of distributed system. First one is concurrency. In a network of computers, concurrent program execution is a norm. Concurrency is about dealing with the simultaneity. I can do my work on my computer while you do your work on your computers, sharing resources such as web pages or files whenever necessary. Next fundamental characteristic of distributed system is no global clock. There is no single global notion of the correct time. A distributed system processes run on different machines, right? There is no shared memory or no shared global clock concept in distributed system. Distributed system is a loosely coupled system. Each node has its own clock. There is no single global notion of correct time. However, the clocks needs to be synchronized for the programs to coordinate and cooperate, right? Direct consequence of the fact that when programs need to cooperate, they coordinate their actions by exchanging messages through TCP/IP network. Only communication is by sending messages through a network. The distributed system has three fundamental characteristics, and the last one is independent failures. All computer systems can fail. Distributed system can fail in new ways. Faults in the network result in the isolation of the computers that are connected to it. But this does not mean that they stop running. The programs running on them may not be able to detect whether the network has failed or has become unusually slow. Failure of a computer or a crash is not immediately made known to the other components with which it communicates. Each component of the system can fail independently, leaving the others still running. The system failures is not known to other components with which it communicates. Features like replication, world server services makes this happens. Let's move on to the last topic of today's class, distributed computing versus centralized computing. Early computing was performed on a single processor. Uniprocessor computing can be called centralized computing. Distributed system is a collection of independent computers interconnected via a network capable of collaborating on a task. Distributed computing is computing performed in a distributed system. Let's have a look at the advantages of distributed system over centralized system. Economics wise, microprocessors offer a better price and performance than mainframes. In distributed systems, many components that are spatially separated are involved. Speed. A distributed system may have more total computing power than a mainframe. Inherent distribution. Some applications involve spatially separated machines. Reliability. If one machine crashes, the system as a whole can still survive. Incremental growth. Computing power can be added in small increments in the case of distributed system. Today's presentation ends here. Thank you for listening.